In my previous video, we discussed the formula that you can use to find the roots of quadratic equation. To find the sum and product of the roots of quadratic equation without first solving the equations. From there, we were able to derive this equation alpha plus beta, that is sum of roots of a quadratic equation, is equal to minus b over a. And we also derived this expression alpha beta, meaning product of roots of quadratic equation is equal to c over a. Now, having derived these expressions, we now want to discuss some symmetric expressions involving the roots of quadratic equation. Now, what do I mean by symmetric expression? That is, if the variables that are involved are interchanged, then the expression remains unchanged. For instance, alpha plus beta is a symmetric expression because alpha, if I interchange this as beta plus alpha, we are still going to get the same value. Now, there are some other symmetric expressions that examiners normally want students to solve, such as alpha square plus beta square. Don't forget, alpha and beta are the roots of quadratic equation. So if you are asked to find alpha square plus beta square, we don't know the root that is alpha and we don't know the root that is beta. So how can we simplify this expression? Alpha square plus beta square. So now, in order to do this, we are going to make use of the knowledge of algebraic expression. The knowledge of algebraic expression. This expression comes from the parent expression. What is that parent expression? Alpha plus beta raised to power of 2. This is the parent expression from which this alpha square plus beta square is formed. Now, how is it formed from there? Now, let us do this expansion. Alpha plus beta all square. In order to expand this, there is a shortcut which I have discussed several times in my video. So alpha plus beta square is equal to alpha to the power of 2, then plus alpha times beta times 2. That will give us 2 alpha beta. Then plus, take this beta, then beta to the power of 2, plus beta to the power of 2. Now, if you can see this expansion, this alpha square plus beta square can be made the subject of formula from this parent expression, as I've said. So in order to make alpha square plus beta square the subject of the formula, then we are going to subtract these 2 alpha beta from this side and from this side. Now let us do that. Alpha plus beta all square minus 2 alpha beta is equal to, then from this side too, we want to subtract, alpha square plus 2 alpha beta plus beta square minus 2 alpha beta. Now, plus 2 alpha beta will cancel minus 2 alpha beta to become 0. Then we will be left with alpha square plus beta square. So therefore, whenever you are asked to simplify the value of alpha square plus beta square, then you'll be able to say alpha square plus beta square is equal to alpha plus beta raised to power of 2 minus 2 alpha beta. And this is the expression from which alpha square plus beta square was formed. Don't forget I said it was formed from this parent expression. So whenever you are asked to find alpha square plus beta square, just make use of this relation. You can commit it into your memory. Now what I've just done is to derive how it was formed. So alpha square plus beta square is alpha plus beta raised to power of 2 minus 2 alpha beta. Now, how can we apply this? I want to do that now. Permit me to rub off the board. Now, if 2x squared minus 3x plus 5 is equal to 0 is a particular quadratic equation, then we are asked to find alpha square plus beta square, that is square of one of the roots plus square of the other roots. So we don't need to waste our time. So just write alpha square plus beta square as alpha plus beta raised to power of 2 minus 2 alpha beta. So with this, we can now make use of our formula for sum of roots, which is alpha plus beta, that is minus b over a. Then from here, our b is minus 3. So we have minus 3 all over, then a is equal to 2 all over 2. Then minus times minus, that is plus, so this is 3 over 2. So 3 over 2 is the sum of roots of this equation. Then what about product of roots, which is alpha beta? And that is c over a. So c is equal to 5, while a is equal to 2. So product of the root of this equation is 5 over 2. Therefore, alpha square plus beta square is equal to sum of the roots raised to power of 2, and that is 3 over 2 raised to power of 2 minus 2 times product of the roots, which is 5 all over 2. Then this is equal to 3 square, that is 9, all over 2 square, that is 4. Then minus 2 times 5, 10, or let's use these 2 to divide this. 2 here 1, 2 here 1. So 1 times 5, that is 5 all over 1. Then we can find the LCM of 4 and 1, and that is 4. 4 divided by 4, that will give us 9. Sorry, 4 divided by 4 will give us 1. Then 1 times 9, that is 9. Then minus 4 divided by 1, that will give us 4. 4 times 5, that is 20. So 9 minus 20, that is minus 11 all over 4. And that is the value of alpha square plus beta square. Now, I want to also look at another symmetric expression. And that expression is alpha cube plus beta cube. Alpha cube plus beta cube. That is sum of the cube of one of the roots and the cube of the other roots. Now, how can we derive an expression for this? This one also was derived from a parent expression, and that parent expression is alpha plus beta all raised to power of 3. This is the parent expression from which alpha cube plus beta cube is derived. Now, let us do this expansion. Alpha plus beta raised to power of 3. Now, if you are familiar with Pascal triangle, you can easily expand this expression. Now with Pascal triangle, we have these steps. So I'm going to discuss this Pascal triangle into details in another video, where you will learn how to expand algebraic expression without wasting time. So now we want to make use of this coefficient. So from here, alpha plus beta raised to power of 3 is equal to alpha raised to power of 3 plus 3 alpha square beta plus 3 alpha beta square, then plus beta raised to power of 3 plus beta raised to power of 3. As I said, we are going to discuss how to make use of Pascal triangle for algebraic expansion. Now, how can we arrive at alpha cube plus beta cube from here? So that means you are going to subtract 3 alpha square beta plus 3 alpha beta square from this equation, from this expression, and from this expression. And if we do that, we are going to have alpha plus beta raised to power of 3 minus 3 alpha square beta, then minus 3 alpha beta square, then that is going to give us only alpha cube plus beta cube. So we have subtracted this 3 alpha square beta and 3 alpha beta square from this side. So now alpha cube plus beta cube is now equal to alpha plus beta raised to power of 3, then minus, I want to factorize this expression. And what are the common factors? 3 is common, alpha is common, then beta is common. Then open bracket, if minus 3 alpha square beta, minus 3 alpha square beta, if you use it to divide minus 3 alpha beta, we are going to get minus, we cancel minus, 3 we cancel 3, beta we cancel beta, alpha we cancel this, then it will remain 1 alpha up. So this is alpha. Then if you use minus 3 alpha beta square minus 3 alpha beta square, if you use it to divide this highest common factor, minus 3 alpha beta, minus we cancel minus, so that will become plus, 3 we cancel 3, alpha we cancel alpha, then beta we cancel this beta, then beta we cancel this, it will remain 1 beta. So plus beta. So now alpha cube plus beta cube excuse me, is equal to alpha plus beta raised to power of 3 minus 3 alpha beta, open bracket, alpha plus beta. How can we now apply this? Let us do the application. So don't forget, alpha cube plus beta cube is equal to alpha plus beta whole cube minus 3 alpha beta, open bracket, alpha plus beta. Just commit this into your memory. In your exam, you might not be asked to derive it. So commit it into your memory. Now let us apply this. Assuming 2x squared rather, plus 5x minus 6 is equal to 0 is a quadratic equation. Then we are now asked to find alpha cube plus beta cube. So all we need to do is to just say alpha cube plus beta cube, as we have derived, is equal to alpha plus beta all cube minus 3 alpha beta, then open bracket, alpha plus beta. So with this, we are good to go. Now, alpha plus beta is equal to minus b over a. And that will give us, b is plus 5. So that will give us minus 5 over a is 2. Minus 5 over 2. And what about alpha beta? Product of roots. That is c over a. And c is minus 6. While our a is 2. So minus 6 over 2, that is minus 3. Now, having known alpha plus beta and alpha beta, you can just impute them into this expression. So alpha cubed plus beta cubed is equal to alpha plus beta, that is minus 5 over 2 raised to power of 3. Then minus 3 times alpha beta, that is minus 3. Then times alpha plus beta, that is minus 5 all over 2. Then this is equal to minus 5 raised to power of 3. That is minus 5 times minus 5 times minus 5. And that will give us minus 125 all over 2 times 2 times 2. That will give us 8. Then minus times minus here will give us plus. Plus times minus will give us minus. Now 3 times 3, that is 9. 9 times 5, that is 45. Then all over 2. Now the LCM of 8 and 2 is equal to 8. 8 divided by 8, that will give us 1. Then 1 times minus 125, that is minus 125. Then minus 8 divided by 2, that is 4. Then 45 times 4, that is 180. Now minus 125 minus 180, that will give us 502. So minus 305 all over 8. And that is the value of alpha cube plus beta cube. Alpha cube plus beta cube according to this equation. Now, having learned this, we now want to also derive an expression for this. We want to derive an expression for another symmetric expression. Okay, I have in mind alpha minus beta. Alpha minus beta. Now, how can we get alpha minus beta? Alpha minus beta can be obtained from the parent expression alpha minus beta raised to power of 2. Alpha minus beta raised to power of 2. Now, let us open this bracket. Alpha raised to power of 2. Then alpha times minus beta times 2. That is minus 2 alpha beta. Then minus beta raised to power of 2. That will give us plus beta square. Then from here, alpha minus beta whole square is equal to alpha square minus 2 alpha beta plus beta square. And we can rewrite this as alpha square plus beta square, then minus 2 alpha beta. But don't forget, in my previous video, we have discussed this. Alpha square plus beta square is, this alpha square plus beta square is alpha plus beta raised to power of 2 minus 2 alpha beta minus 2 alpha beta. And this is equal to alpha plus beta raised to power of 2 minus 2 alpha beta minus 2 alpha beta. That will give us minus 4 alpha beta. But since it is only alpha minus beta, we are going